Welcome to Maths Memory, and this is a gold tier topic, complete the square. It's grade 8 and is found on higher level papers. So let's get a card and let's write the following templates. We're very used to that now, and let's go through these learning objectives in turn. So the first thing I'm going to show you on this video is how to find, let's say, constants P and Q in this format over here. Alright, it's very important you understand this format, and it comes up quite often. And once you have this format, we can find a few more things. Find a turning point. It can be a minimum or max. I'm going to show you a nice shortcut how to do that. How to sketch a graph can be quite complicated, but again, I'm going to show you how to find the roots on the x-axis, and also when the coefficient is not 1, how to deal with this in this way. So again, it's a grade 8 topic. Any examples, leave a space for your best questions you'd like during this video, and hopefully we'll get to 3 clear steps at the end of this, so you will be quite happy with this video. Let's turn over for the toolkit. Let's get a revision card. Let's call it toolkit. Let's make 3 clear sections A, B, and C on this video. We're going to show you the top tricks on complete the square. So press pause on this card. Question 1, cool 1. Press pause, write this question down, parts A and parts B. Press play when you are ready. So this is the first question of complete the square, and part A is basically looking for the most basic form you can get in this format over here. So when you see this format, you got to think of complete the square. They'll very rarely say this in the words of complete the square. Okay, so this is how you this is the format of the formula for this. So the first thing we do is we want to define A and B, integers A and B, which are whole numbers. Let's do it like this. This is the quickest way we know it. So look at the B coefficient, which is 4, and what we're going to do is half that. So if we half that, we get 2, and we ignore the x over here. So we'll put it straight over here. So it'll be x will be the same as this, plus 2 squared. The squared is the same as the squared over here. So remember, all we're doing is doing a couple of things already. We're halving the B coefficient and getting rid of the x. We're now taking away this number over here, the plus 2 squared. Well, alright, plus 2 squared or squared. It's very important to remember that this minus is outside the bracket, and then we're going to basically add whatever we see outside over here. If it's going to be a minus 1 in the original question, we'll put a minus 1. So the final answer is x plus 2 squared minus 4 minus 1, which simply is x plus 2 squared minus 5. So here you can quite clearly see what A and B are. We've got A defined as 2 and B as minus 5. So just look through that. We can just write these over here as well. A is 2 and B is minus 5. So let's look at part B now. The part B is looking at the turning points. So we should know what turning points mean. Turning points is obviously a curve we're looking at. To do with x squared graphs or x cubes you could have as well. So it's quite an easy, simple way of doing this. I mean, think of it obviously as the best way of finding the turning point is from this format over here. So we have x plus 2 squared minus 5, and let's write y equals this as well. Okay, so the turning points are from part A, let's say. Now we know basically that the lowest minimum point of y would be when this whole thing over here is actually going to be 0 at its minimum, because you can't square obviously let's say a negative number and get a negative number. The lowest possible value after you square any number will be 0. So if this whole thing will be 0 in this bracket, the question arises, what value of x should be over here to give you 0? This whole bracket squared should give you 0. So x would have to be minus 2. When x is minus 2 plus 2 is 0. 0 squared is 0. And 0 minus 5 will be minus 5 over here. So a little shortcut, we can look at this over here more carefully. The minus 2 will always be the opposite to this plus 2 over here. So if it's a plus 2, it'll be obviously always the opposite sign. And this one over here, the y coordinate, the minimum value, would always be this leftover number over here. That's the actual shorter way of doing this. Press pause on this toolkit revision card. This is section A, and this is what we have just shown you, how to interpret the basics and how to find a turning point on a given complete the square problem. So look at this, and look how we have shown you how to find out P and Q, and also the turning point, a quick way of finding out the turning point once you have it in this format. Minus P, comma, the leftover bit, which is Q. Press pause to make sure you get this. Question 2, core 2. So press pause, write part A and B down, and press play when you are ready. So write x squared minus 3x minus 2 in the form x plus p squared plus q. So again, this is complete the square over here. We need to find out what p and q are. So let's do what we did in the original question. Let's first of all halve this b coefficient. So let's make it x minus 3 over 2 squared. Notice how we are using a top heavy fraction over here, not a decimal. You'll see why in a minute. Now what we do, we take away this number squared. Now 3 over 2 squared is much easier to square, obviously, a fraction than the decimal. That's why we do this. So that will be 9 over 4, and then we're going to simply take away the number we see in the original equation, which is minus 2. So let's sort out the last bit because we want to make that look a bit easier. So this bit over here, we're going to make it into like one whole fraction. So minus 9 over 4 minus 2 over 1. So this will simply be, we can make this 4 over here. We can make this minus 9 and minus 8 from taking away fractions. Minus 17 over 4. So our final answer would be this. The final answer would be x minus 3 over 2 squared minus 17 over 4. So we've got two answers over here. We've got the p number and we've got the q number over here. P and q. Let's define both of those over here. So p equals minus 3 over 2 and q equals minus 17 over 4. So let's look at part B. Now part B is a bit more complex. It's asking us to find the roots of the equation. The roots simply mean the solutions, the answers of finding x, basically. So let's use our answer for part A and let's see what we can do to find the roots of x, two values of x, because obviously it's an x squared function over here. So we've got this. So next step, let's make it equal to 0, because if y equals 0, that's why the roots always happen with y equals 0. It crosses over the x-axis. So let's get this minus 17 over 4 to the other side. Let's do it like this. X minus 3 over 2 squared equals 17 over 4. Now let's square root both sides. So x minus 3 over 2, we'll get rid of the brackets, equals the square root of 17 over 4. We'll put a plus and a minus because you can have two positives times positives to give you this, or negatives and negatives to give you that. And now we're going to do the final value of x. X equals, let's say, the positive version, root 17. Let's say over 2 in this case, because we can square root the denominator over here. Plus 3 over 2. That's one solution. And the other solution would be this. X equals root 17 over 2 again. But this would be now the minus version, remember, because of the minus version over here. Plus 3 over 2. We can simplify both of these. This would be, obviously, if you make this to a nice number, a big denominator over here, 2. It'll be 3 minus root 17, if you can see that, okay? And this would simplify to be a big denominator over here, and this would be 3 plus root 7. So those are your two values of x that satisfy this equation. Well, obviously, when y is 0, you have two roots. First root being this one over here, and the second root being this one over here. Question 2, continued, part C, core 2. So press pause, just look at this question of how to sketch it, try to sketch this graph, and press play when you are ready. So we're continuing from question 2 now, part C, and we're learning to sketch a graph. Now to do this, we'll need several things, I would say 3 main categories to do this, okay? And a fourth just on the icing on the cake. Now, let's remind ourselves what we had before. We had a answer of this, x minus 3 over 2, and we had minus 17 over 4. So that was a way we actually wrote this. We could write y equals, if you want to find the min or the max. So, and from there on, we looked at, that was part A, and then we looked at part B, which was finding the roots. And the two roots were Let's do the negative version first. 3 minus root 17 over 2 over 0. And it was 3 plus root 17 over 2 over 0. That's part B, I believe, the roots. So number 3, we want to sketch this. Now, let's have a look. How can we use this info to do this? So the first thing we want to do really is to think of general shape over here. Now, obviously, this is a parabola, x squared. It has a positive a coefficient, hence it'll be a U shape with a minimum, okay? If this was obviously a minus, it'd be a minus one. So general shape is a U shape. We're happy with that. Let's have a look now at number 2. Number 2, now what we want to do is find out where does it cross the y-axis when x is 0. So we look at our original equation over here, and when x is 0, we plug in x is 0 into here, 0 squared, 0 here as well, minus 3 times 0, minus 2. So basically we're left with a minus 2 over here. So it's 0, comma, minus 2. This will be our point on the y-intercept over here. Number 3, let's look at where it crosses the x-axis. This is what we did from part B over here. It's got these two coordinates over here. I won't write them out again. You can see it from the left hand side. If we look at this on a non-calculator, root 17 is simply something just above, let's say, 4. So 3 minus 4, it's a negative version, roughly about 1, just below 1, let's say, 1 minus a half. Let's put this over here. And this one, 3 plus roughly 4, 7 divided by 2, 3.5. Let's say roughly over here. So it can just approximations. That's this section over here. Now the fourth one, the icing on the cake, is the minimum value. The minimum can be used from part A over here. The minimum value is going to be 3 over 2, the opposite value, remember, and the leftover numbers, minus 17 over 4, which we can see over here. Okay, so 3 over 2 is 1.5, 1.5 across, and minus 4 and a bit down. Let's say it's over here. That should be this. Now, I'm not the best at drawing, but let's have a look and see how we can draw this line over here. So let's quickly do a nice U shape. So we'll join them all up through here, through here, through here. Try to get a curve if you can, and up here as well. And that should be a sketch of this. Remember, a sketch is not plotting it. It's just something to show the key coordinates on each of the axes and the minimum over here. So follow this 4 steps and you can't really go wrong with this. On your toolkit, let's do section B, and we have shown you just how to sketch a graph. Sketching a graph on this in this way is used in any topic in maths basically, but this is just for complete the square. The 4-step guide: general shape, y-axis intercept, your x-axis intercept, and then your turning point. Press pause on this. Question 3 challenge. So press pause, write parts A and B down, press play when you are ready. So write 2x squared minus 10x plus 3 in the form of this. So obviously the thing that is new to you is this 2 coefficient in front of the x squared term, okay? We need to find out the value of a. So let's deal with it. Well, there are a couple of ways of dealing with it. Let's do the most simplest way possible. Let's divide, first of all, everything, well, not everything, just the b coefficient by 2. We're going to create a square bracket over here, x squared minus 5x. Okay, and put a plus 3. So this way we're dealing only with the first, let's say, 2/3 of this. Okay, we're only dealing with that. We're not going to look at anything else. The 3 we'll bring in at the end. Let's now complete the square on this first bit. So we can have 2 square bracket, curly bracket, complete the square on this, minus 5 over 2, curly bracket. And let's take away, obviously, this number squared, 25 over 4. Okay. And now let's put the square bracket and we'll put plus 3. Again, we're only looking at the, let's say, this bit over here. Okay, what concerns us over here? Ignore the 3 from the outside. So now let's basically, again, do what we do before in a normal complete square scenario. Let's ignore the 2 outside. Let's basically now multiply everything by 2 because of the 2 over here. Let's get rid of the square bracket. So we're going to multiply this by 2 over here. Let's show you how we do this. Multiply this by 2 and also multiply this by 2 as well. So we get 2 curly brackets, x minus 5 over 2 squared, okay, minus 50 over 4. The way we got 50 was obviously doing 2 over 1 times 25 over 4 to give you this number. And what we're going to do now is to add the 3 over here. So the square brackets go. Now we want to obviously get a nice number after this. we want to get a nice number like we did before, simplify these two. So we're going to look at this and say to ourselves, minus 50 over 4 plus 3 over 1. So this should give us a big common denominator of 4 minus 50 plus 12, which is minus 38 over 4. We'll simply link it on now to what we had over here before. So this will give us a nice final answer of x minus 5 over 2 squared minus 38 over 4. So that would be the final answer for part A of how we would deal with something with a non-1 value for the x term. Now turning points are pretty simple. It doesn't really affect anything over here. The turning points would be, if we look at this, how do we make this whole thing equal 0 over here? We want to make this whole thing equal 0. Okay, so that too wouldn't really affect it. If you look at it like this, it's the same concept as before. The trick is to make this number the opposite of minus 5 over 2. So it's 5 over 2, comma, and the leftover number is minus 38 over 4. So that would be your turning point over there. On your revision card, part C, this is my toolkit. We have just shown you again on maths memory how to deal with a quadratic when the coefficient of x squared is not 1, how to use square brackets first, divide every single thing by that number, factorize it, and then use your, let's say, curved brackets in the usual way on how you complete the square. Press pause to make sure you get this. So we have finished now your maths memory complete the square video, and let's see what you have got from this. So let's get a card out. Let's see what you have actually ticked off. First thing on our learning objectives, have you learned how to write complete the square in this format over here when P and Q are clearly defined? Have you learned how to find a turning point from this format over here, whether it's a minimum or maximum? Have you learned to sketch a graph in 4 steps? That's vital as well. And also, have you learned how to, let's say, complete the square when you have the coefficient of x squared, which is not 1, how to deal with square brackets? If you feel you've mastered those 4 points, give yourself a tick over here. Look at the best examples you got from this video, put them in here as well. And we haven't got any 3 clear steps because this is quite a big topic. But anyway, if you've got the ones above here, I'm sure it's good enough. Let's turn over to our consolidated toolkit. So this is our toolkit all put together to make sure you can attempt these Let's Do It questions in the best way possible with your revision cards. So part A, basics and turning points. Make sure you've understood these points over here, sketching a graph, and finally how to deal with a equation where your coefficient is not 1. Press pause, make sure you've got this, and let's do our Let's Do questions based on this information. Question 1, let's do it. So write down parts A and B for question number 1. Try your best to do these parts and press play when you are ready. Question 2, let's do it. Press pause, write this question down, sketch the graph of this equation, find complete the square, and press play when you are ready. Question 3, let's do it. Press pause, write this question down, see if you can prove that this has got no real roots, and press play when you're ready. Well done on finishing this topic on complete this square. Again, this is week 19. This is a core grade 8 topic 2 gold tier. So how well have you understood your revision cards, and more importantly, things like getting a basic format in terms of finding coefficients A and B on a quadratic, finding turning points, sketching a graph, things like that. If you've understood this, give yourself a mark on your revision planner and rate yourself out of 10. This should be definitely based on how well those Let's Do It questions have been tackled using those revision cards you had previously created on this topic.